In this video, we will look at bitumen. Bitumen is a semi-solid component of crude oil. It is produced during the oil distillation process that also produces propane, kerosene, petrol, diesel, and other petroleum products. It is also referred to as tar, asphalt, or pitch. In its purest form, at room temperature, it is a black resinous solid substance of very high viscosity. Viscosity is the measure of the substance's resistance to flowing. Substances with low viscosity, such as water and kerosene, will flow very easy, while the substances with high viscosity, such as honey and oil and bitumen, flow more slowly. At room temperature, bitumen has a very high viscosity, such that you cannot detect any flow. However, if it is heated, its viscosity will reduce and it will flow, but still very slowly. Usually, it is heated to around 150 to 180 degrees centigrade. Bitumen starts to burn or ignite at about 230 degrees centigrade, so the working temperatures provide a good safety margin. You can also add less viscous substances, such as kerosene, to lower the viscosity even more, to allow the bitumen to be sprayed over the road as is required for a chip seal, and to soak into the base course as required for a first coat seal. Bitumen with kerosene mixed in is called cutback bitumen. When it is heated, bitumen also becomes very sticky and will adhere to most substances. This means the bitumen is able to provide a strong bond between the base course, or previous road surfacing, and the aggregate. This strong adhesion is essential if the traffic loads are to be transferred to the base course. Another feature of bitumen is that it is highly impermeable. That means that water cannot soak through even a thin layer of bitumen, which enables it to waterproof the road surface. It is also insoluble in water, so it is not prone to chemical breakdown by contact with water. Over time, bitumen hardens and becomes brittle. This can lead to cracking and loss of aggregate from the road surface. Therefore, bitumen surfacings need to be replaced every 10 to 15 years. This replacement often just involves laying a new surface over the existing and is called a reseal. Bitumen can vary in hardness, and in New Zealand, the bitumen grades are determined by the hardness of the bitumen. This hardness is determined by the penetration test, which basically involves measuring the penetration of a needle weighted by a 100 gram weight over a 5-second period. The amount of penetration is measured in tenths of a millimeter, and the bitumen is graded according to that value. For example, a bitumen that has a penetration of 14 millimeters over the 5-second period, that is 140 tenths of a millimeter, would have a penetration value of 140 and would be a 130-150 grade bitumen. In other words, it falls between 130 and 150 penetration grades. 180-200 bitumen has a penetration of 18 to 20 millimeters over the 5 seconds and are the softest bitumens. They are the most common grade used for chip sealing in New Zealand. However, 130-150 grade may be used in hotter climates. This is because the softer grade, 180-200 bitumen, is more prone to becoming excessively soft in hot weather. When it is too soft, the bitumen cannot hold the chip in place and the chip may be stripped out by traffic loadings, leaving just a bitumen surface remaining. This bitumen surface is more prone to wear and has poor skid resistance, especially when wet. Harder bitumens can be used for asphaltic concrete, as it does not need to flow as well as the sprayed bitumens for chip seal. The HE01 grade bitumen is usually used for asphaltic concrete, although grade 60-70 may also be used for higher traffic loadings. The harder bitumens are more rigid, but are also more prone to becoming hard and brittle in cold weather, which can result in cracking. The required properties of bitumens to be used on roads is set out in NZTA M1 specifications for roading bitumens. These properties include penetration, which was discussed in the previous slide, viscosity, flash point, purity, and weatherability. We looked at hardness in the previous slide. It is tested by the penetration test. Viscosity is the measure of the substance's resistance to flow. Bitumen needs to have a low viscosity to allow it to be sprayed and mixed, but a high viscosity in service so it can resist traffic flows. So there are two measures of viscosity for a bitumen. The first is its viscosity at 60 degrees centigrade, which is the hottest temperature that a road is likely to experience in service. This test measures how effective the bitumen is in service, and the specification has a minimum value below which the bitumen is not suitable for use on a road. If it is too viscous at that temperature, then it is unable to hold the chip in the surfacing layer under traffic loadings. The other situation is the viscosity of bitumen when it is heated to 135 degrees centigrade, which is slightly below the normal temperature at which bitumen is heated for spraying and mixing. This test gives an indication of the bitumen's ability to be sprayed or mixed when heated. Bitumen is a hydrocarbon like kerosene and petrol, which means it burns well if ignited. A flash point is the temperature at which a substance starts to ignite. Once ignited, the heat of the burning material sustains the burning as long as there is a combustible material and air available. It is important that the bitumen does not start burning when heated to its spraying or mixing temperature. Therefore, the flash point test is designed to determine at what temperature a bitumen will start burning. The latest versions of the specification, issued in 2011, sets a minimum flash point of 218 degrees centigrade for all bitumens. That means that they should not start igniting at any temperature below 218 degrees centigrade. The normal spraying temperature for bitumen is 150 to 180 degrees centigrade, so the specified minimum flash point temperature produces a safety margin to minimize the risk of the bitumen igniting while being laid. The bitumen needs to be relatively free of mineral matter or carbon, as these impurities can adversely affect the bitumen properties if present in high enough levels. The test is done by dissolving the bitumen in a solvent that dissolves pure bitumen but does not dissolve the impurities. That means that what is left after the bitumen is dissolved is the impurities. The specification requires that 99% or more of the weight of the sample of bitumen is dissolved, indicating that only 1% or less of the bitumen can be impurities that remain after the pure bitumen is dissolved. Bitumen hardens and becomes brittle over time through being exposed to the atmosphere. This hardening is caused by chemical changes caused by oxygen in the air. The risk of cracking and the loss of chip increases as the bitumen becomes harder and more brittle. The specification requires that this property be measured using the rolling thin film oven test. In this test, the penetration value of the sample is first determined. The sample is then rotated in a drum to create a thin film of bitumen while blowing hot air over it for 85 minutes. This creates some hardening of the bitumen. A penetration test is again undertaken and the degree of hardening determined by comparing the before and after penetration test result. The specification requires that the after-test penetration value be at least 50% of the penetration before the test. As mentioned, the viscosity of bitumen can be reduced by heating. However, heating alone will not usually provide the low viscosity required to construct a road seal. The viscosity can be lowered further by the addition of kerosene or some other petroleum oil that mixes with the bitumen. The substance mixed in with bitumen, usually kerosene, is called a cutter, and the mix is called a cutback bitumen. The more cutter you add, the less viscous the cutback bitumen becomes, and the easier it is to mix or spray. Kerosene is a volatile substance, which means that it evaporates quickly. When a cutback bitumen is laid, the kerosene starts evaporating, leaving the bitumen on the road surface. Basically, the cutter is added to allow the bitumen to be sprayed or mixed, but then it evaporates to leave the hard bitumen behind. This is exactly what we require for a road surface. We need to be able to spread the binder and have it soak into the base course, and for aggregate to create a strong adhesion with it, but we need the bitumen to harden to provide a strong bond between the base course and the chip and to hold the aggregate in place under strong traffic loadings. Cutback bitumen is used for both chip seals and asphaltic concrete, although the cutter content varies according to the use and surrounding temperature. Cutback bitumens used in chip seal usually have a cutter content up to 10%, depending on the weather, to provide a mix that can easily be pumped and sprayed. Asphaltic concrete has a binder and aggregate mixed at a batching plant and is laid as one substance. This process does not require the cutback bitumen to be so viscous, so the kerosene content of cutback bitumen used in the production of asphaltic concrete is usually only about 5% or below, depending on the temperature.